Disclaimer, presentation. So here's the outline. Nitrogen and phosphorus are these pollutants. They're having widespread degradation across the United States. We're encouraging states to develop numeric nutrient criteria. And we have this N-STEPS program to help you get there, at least on the technical end. And I forgot what N-STEPS stands for. Oh, you have it? Okay. It doesn't matter. So this is basically, if you call us, we'll work with you. There's some folks at Tetra Tech that can do this work, and they can help you out. This is the geekiest slide I've ever seen. All right, so let's have some chemistry, biochemistry. What is this? Anybody?
What are you pointing at? I can't see your pointing at.
DNA. Oh. DNA. What are these?
Amino acids.
Amino acids, yes. This is the hard one. What is this? Krebs or Calvin?
Krebs cycle.
Krebs cycle? Okay, I'll go with that. And what is this?
Membrane.
A membrane, right. That's basically where the work is happening. So the main point of this geeky slide is to really illustrate that nitrogen and phosphorus are essential to life. They're in our DNA, no pun intended. And so we rely on nitrogen and phosphorus. And I'm just taking an aside. We've actually, in my view, shifted the nitrogen cycle pretty far to the right. So here's the diversion. Who knows what the Haber-Bosch process is? Excellent. So the Haber-Bosch process was, before the Haber-Bosch process, to get nitrogen, you needed to go to Argentina or Chile and scrape guano. After the Haber-Bosch process, they learned how to take nitrogen out of the air and use it for things like TNT, because that's a good thing during the wars, but also agriculture. So this process, this Haber-Bosch process, is really what was responsible for the Green Revolution. And estimates are that this Haber-Bosch process is responsible for about 1/3 of the population of the planet. Just imagine that. And you think there's not going to be an effect. So there's really two ways that we think of nutrients sort of affecting aquatic life uses. So one is the competition pathway, right? So actually, let's go to the productivity pathway, because this is the one most common that folks think about. So increase nutrients, need to increase primary production, you get respiration, you have a bunch of biomass, leads to sags in DO. You know, it sort of covers the, what causes problems, decreased water quality, loss of vegetated habitat because the things that were growing can't grow because of a bunch of algae on top. And it causes, problems with disinfection byproducts, right? Chloramines when folks try to treat it. And that can affect, aquatic life and recreation and drinking water, right? So that's sort of the classic eutrophication model. This other one is more interesting and probably a bigger thing here than, this we see in the dead zone, when all the water's coming down the state from Mississippi. This is an interesting one. So what happened is we have some primary producers, phytoplankton that likes certain types of algae and not the other. Harmful algal blooms do a lot better under these conditions. It leads to, the things that eat the phytoplankton don't want to eat those because they're not that tasty. They produce toxins, there's scums, there's odors, also disinfection byproducts, and it affects these aquatic life uses, right? So Nitrogen and phosphorus can affect beneficial uses in a number of pathways. This last one is one that we've sort of known about for a while, but most people don't know about it. Some people call it the brown pathway. And it's basically, instead of chlorophyll, this is basically bacteria, so it's heterotrophic respiration, leading to the same type of things that affect aquatic life. So all of those things are really, really important, and that's why if you want to protect aquatic life use, if you want to protect all these uses, you gotta start here. This is work by Suzanne Bricker. It was done, over a decade ago, and it was really looking at how well are our estuaries doing, and is there risk? And so, let's see, where's San Francisco Bay? It is moderate risk. I'm sorry, Hawaii, you're not on here. Huh? Yeah, you're fine, yeah. And this was sort of the framework that she used to identify this. So again, this is the eutrophication pathway. That's fine. Then you get some growth. It sort of closes out some of the light, and you get worse conditions. Dang it. All right, so here's the dead zone, classic eutrophication, right? The Mississippi River drains about a third of the US. It's an amazing amount of land, all ending up in this one place and causing this dead zone. What is the dead zone? It's the classic eutrophication, right? So imagine that, 870, almost 9,000 square miles. Who knows what this is? Not you, Meredith. Any guesses?
Harmful algal blooms, cyanotoxins.
That's it. Oops, darn it. Yeah, so there's, I'm assuming this is microcystin, and this is sort of the formation of microcystin. So that's sort of a nasty one, right? And yeah, this is just to show that nutrients are impairing waters. It shows up in the 303D list of everyone across the nation. It's usually like the top 2, 3, or 4 in most states. These are the national numbers. And as a result, it's causing a lot of folks to develop TMDLs. And this is really hard. You can't just turn the knob, right? If you want to upgrade a treatment plant, it's going to cost, hundreds of millions, billions of dollars. If you want to start dealing with ag, that's going to cost you hundreds of millions of meetings. So, so I pulled this from the last 303D list that I had, and this is Region 9, so most of you folks, you guys are accepted. Hawaii, I thought you said you were good. Yeah, they have lots of little teeny ones. So this is really just to illustrate, and it's in your package that, it's not just the Gulf of Mexico. It's a lot of places that have problems, and I think the problem is actually quite bigger than we're showing up in our data. Huh?
We have narrative water. Drinking water. Those are probably a lot of you.
Yeah.
Just remember, we have narrative, nutrient objectives in all of our basin plans.
Yeah.
And also those numbers for California reflect low DO and other nutrient-related parameters. So they may not be for nutrients themselves, but there's other listings related to that.
Yeah, but some of it's biostimulatory too. So this is the Clean Water Act, and I don't know why we're repeating it, but the integrity, protection, propagation. These are the regs that we've been talking about all the time. And again, the really important things is you got to protect the designated use, have good science, show your method, show your work, have a good scientific rationale, right? So EPA is really concerned about this, and we're doing a lot. We have a bunch of strategies and technical documents. We developed 304A criteria in 2000 for all the lakes and streams across the nation. We have a strategy for developing nutrient criteria, and we have a ton of technical documents. These are just some of them. And you want to just Google EPA nutrients, and you'll find most of these. These are some examples of narrative criteria. We have Arizona and Regional Board 5, so yay, Regional Board 5. They're slightly different, but in concept, they're not too different. Yeah, Kevin.
Guess I'll point out with these two examples, they're linked to all beneficial uses. So this is just an example of old basin plan language that doesn't connect it to a particular beneficial use. It doesn't say warm, doesn't say cold.
That's
doesn't
right.
even say aquatic life.
Yeah.
It just says any beneficial use.
Yeah.
So that happens.
It happens, yeah. And it would be better if we had more precise narrative criteria and then more precise numeric criteria. This is the status of states with numeric criteria. It is not overwhelming. So the scale here, California looks good, but it's good because some regional boards have nitrogen criteria. San Diego has, and Region 6 has. So you make California look good, but besides them, California is pretty white. Hawaii and all the territories have numeric criteria for all their water bodies in their state. They were done like in the 70s, a reference-based approach, and now they're having trouble meeting them. A lot of work has been done up in Minnesota. Florida was the site of lots of litigation, and we actually promulgated in Florida. EPA promulgated. Not that we want to, but sometimes we're compelled to.
Hey, Terry, can I just jump in with an observation that I made when I was at the National TMDL conference a few weeks ago, where I heard a presentation from Florida, and I think it was Minnesota, but it might have been Wisconsin, because all those eastern states run together for me. But both of them had numeric nutrient criteria in place because of lawsuits, because NGOs had sued, and years later down the road, either through state or EPA promulgation, the standards were put in place. So it was a interesting observation from my point of view that it was what was the driver for having those numerics. It seems in most cases is the political pressure, is lawsuits coming from environmental organizations.
Yeah, and Wisconsin and Minnesota are in the Midwest.
Can you tell I'm a California girl?
Yes, yeah, I know that, yeah. They have an N steps program. So the approach that EPA is recommending is an ecological risk assessment approach. Remember I talked about microbial risk assessment? We're talking about a risk assessment approach for nutrient criteria, not just for streams, but for all water body types. Basically, what this approach that's in this document says, develop your conceptual model, like those things that I showed you before, but much more complex. Figure out how you're going to approach it, whether it's going to be a reference condition approach, a stress response, or some sort of mechanistic model. And do your analysis to figure out whether you can just have one big nutrient criteria for the entire state, or whether you have to break it up. And there are lots of different ways to break it up. As I said, some are just eco-regional and some are more fancy statistics. and criteria, duration, and frequency. All right. So this is an example. It's kind of a neat one. It's following that risk assessment paradigm where you identify your goal and you're trying to get this target. And there's these stars, right? You know, that's your goal. Oh, darn it. That's your goal. Here's your target. But between you have some sort of assessment input to know when you're sort of exceeding nutrient criteria or not. And then you got to measure it, right? So that's sort of a logical flow path that folks might want to use. And in this situation, we're using the competition pathway where nutrients lead to shifts, which lead to bad algae, which leads to bad things. Okay, and so the framework is we want to have recreation, so we want to reduce toxins. So to reduce toxin, we want to reduce harmful algae. We're going to use chlorophyll A as a measure, and the target is going to be nitrogen and phosphorus. So this is some work that was done by Lester Yuan at ORD. And he's a very clever guy, and he was using a lot of the information from EPA's National Lakes Assessment, which many states participate in. But before I go ahead.
Sorry, I don't have a mic, but, oh, excellent. Would you mind going back to the other slide? At any point in here, do you assess the amount of flow? Because in water rights, when we think about algae, we think a lot about how much water there is and how fast it can move.
Yeah, so not in this simplified framework, but probably in this one. Let's see. Oh, yeah. But, you know, when you're discussing this to like a management team, you have the simple one. When you're discussing it for, you know, a scientist, you have one that's 10 times more complicated than this, right? So it's really just a way of framing what things I think influence, what things I think are the most important to influence, and what thing I think, you know, are not so important, right? And then just sort of focusing on those things. Oh yeah, before I get to Lester's things. So this is essentially the reference condition approach, right? So Hawaii did this, you know, 40 years ago, 40, maybe almost 50 years ago. It's ocean instead of streams, but they went out and they sampled a bunch of ocean waters. They came up with a distribution, and they based their criteria on, you know, some percentile of the reference population, okay? And that's what they're using to permit and assess nutrients. So there's the reference approach. This is the stressor response approach, where you basically say, I want to plot these things. I want to see if I can find a line, make sure there's a good enough correlation to make this work. If it's, you know, a 0.6 or a 0.7 correlation, you know, we're going to call it good to go for biology. Sometimes you have to break it up. And there's different types of regressions, right? Simple linear, multilinear, quantile regression. That's where you're sort of like doing regression on some percentile, right? Logistic regression. But the key is when you do something like this and you have a decent relationship, you got to pick a threshold, right? So, you know, if you know what chlorophyll is, then you can just kind of go over here and I want this. Or you want to be a little less protective, then you go over here, right, have a higher number, or pick, you know, the outer lower confidence limit to get a more tight number. So these are management decisions that go into the development or picking a number, right? So again, I showed you this competition pathway, And this is Lester's work. So this is really an impressive amount of work to be done on sort of a national scale, and then also to be done at a state scale. So let me walk you through this, if I can. So through the National Lake Survey, they collect algae, chlorophyll, and harmful algae. And they develop this relationship. It's not linear, but some sort of relationship. They also did some sort of quantile regression between cyanovolume and chlorophyll A. So you have those two relationships, you come up with a third relationship. And when you do that, you get, sorry guys, you get this value, right, with the error bars around it. So pretty sweet. So then what Utah did, working with Lester, said, we want to see how we do. So they plotted their data for their lakes on here, and they said, you know what? This relationship, it works. It seems consistent with our expectation of how chlorophyll A, which you can't see here, and microcystin relate. And EPA developed a microcystin number, which is the old one, 8. And so they just said, let's go from 8 down to chlorophyll, and they have some number here that I can't read because it's on a log scale. I'm guessing it's around, I want to say 60 micrograms per liter for this lake, which seems pretty high. So that's an approach, right? It's very nice. We tried to use it in California, but we don't have as much dots for our lakes. Same thing with the National Lakes data. Lester developed a relationship between total nitrogen and chlorophyll. And it's a multilinear regression, so instead of y equals mx plus b, it's, y equals mx plus, z whatever plus b, right? So there's another parameter in there. And this is really, really nice what he did. So rather than try to plot this in three-dimensional space, he just put the contours there. So now you can look at, if I have, chlorophyll A of 10 and nitrogen of 1,000, then in this case I have, sorry, it's not really pointing. This here I have like a, 0.10% chance of having these toxins. So a very, very useful way of displaying the data, and if folks can take advantage of this, I really, really encourage it, because nowhere else you're going to get this density of data in your state unless you've been doing it for a long, long, long time. I keep on walking away from my notes. I'm sorry. So nutrients are different than toxics, right? And so instead of having these lab experiments, a lot of it is done trying to interpret field stuff. Instead of having a nice clean dose response that we had in our health criteria, we're doing correlations. We don't have a dose response really, and we're not looking for lethality. We're looking for these subtle sublethal effects that ultimately have these longer-term effects. And recovery time is longer too, okay? And if we haven't drilled it in your heads yet, criteria need, oh no, it's not this one. Oh, here it is, haha. They have to have the magnitude, duration, and frequency. So it's really important. If I get a sample, what does it mean? Well, you only know when you put it in this context of duration and frequency. So you really want to know, how high it is, for how long a time you're willing to accept, certain levels of chlorophyll A, and over what period you're going to allow exceedances. Is it 10 exceedances over a year, 1 exceedance, and you go on the 303D list? All these things are really, really important questions to sort of think through as you're going through your process of conceptualizing to developing, to going through the process of having a standard that goes to EPA for approval. I like moving. This is just an example of the classification, right? So you're doing all these things, your charts aren't working. Maybe if we separate out geographically, we can do that. Florida and Chesapeake, excellent. This is an example where classification really helps you. So we have this, this is like EPT measure, bugs, and chlorophyll A, and that's a mess. But if you break it up by, different sort of concentrations, you can begin to see patterns. So over here we have a cart regression, which works, right? Those are two different populations. And there's fancier ones like tree regression that allows you to, identify sort of an inflection point. So these things are very, very useful. They're above my intellect, so I have people that do these things. So again, EPA is working really hard with the states to sort of help them, because we know this is a hard slog. And so we will help you with, webinars, white papers, technical resources, national meetings, all of these types of things. We have literature reviews. So all of these things we are willing to help you guys with as you try to develop a criteria for this really hard problem that is causing a lot of subtle problems. So I talked about N steps. I still can't remember what it stands for. But it's basically help from headquarters to the states on some technical aspect. I've got this data, I don't know how to analyze it. Or I'm trying to figure out a better approach to analyze this. Or, geez, I don't know how to do that tree regression. That's what you use these guys for. So it's a couple guys at Tetra Tech who've been working on this for 30 years, and they can help. So just call me, and I will make contact with these guys. And these are the states that are getting help or have gotten help in the past. I noticed that California is not there. So if you want help, let's make it happen. All right. If you have any questions, I will do the best that I can. But if you have really deep and thoughtful questions, maybe you want to talk to these smarter guys. Okay.
Hey Terry, just if anybody else was curious, NSTEP stands for Nutrient Scientific Technical Exchange, Partnership, and Support.
Thank you. That's what I thought it stood for. All right. Any other questions? We're doing well for time? Okay, go ahead, Kevin.
I was thinking about the magnitude, duration, and frequency, and just noting in our basin plans for a lot of our old objectives, we definitely don't have duration and frequency.
Yep.
So for listing and delisting, purposes, we use the binomial distribution for our integrated report. So it's a California specific question, but I'm not sure how to add the binomial distribution approach on top of what you had up here in this slide, I guess 26, for example. So does that mean those assumptions that are in the binomial approach are already addressed when taking this approach? Or
no, they're not.
Okay.
No, they're not. So this is a long and hard question to think about. It's kind of a mind bender. States have sort of used these binomial approaches for 303D listings as sort of an easy way and a transparent way for them to make decisions about listings. And they really should be taking in the duration, frequency, and magnitude that is inherent in the water quality objectives. Most 303D assessments, are based on the California Toxics rules, which are, have a 3-year, time frame. That's their duration. The frequency is not more than once in 3 years. So, that's kind of hard to deal with when you're doing 303D lists every 2 years, right? So the binomial comes in as a sort of a shortcut to do it, and it basically makes the statement that, we really don't want to have our waters, higher than these values for pollutant X more than 10% of the time, right? We want it to be good 90% of the time. And that's really all it is. And so it really is divorced from the duration, frequency, and magnitude. Whether it should be is another question. All right. Yeah, go ahead.
Is EPA looking at the distinction between dissolved phosphorus and total phosphorus in criteria, or is that more of a TMDL question?
Yeah, so this is a hard one. So clearly there are places where you're going to get a better relationship with, soluble phosphorus than total phosphorus, right? But those transformations are happening at rates that are much faster than EPA can manage, right, or states can manage. And so we just sort of say, total, right? Because we know that that nitrogen molecule or that phosphorus molecule is going to change a few times as it goes through the water cycle. And so it's just easier conceptually to deal with the total rather than the parameter that it happens to be at this time. Yeah. Yeah, go ahead, Jesse.
I was just wondering if, since you guys came out with your numbers in 2000 and so few states seem to have incorporated them into their own, is there a plan to redo those numbers, or is that what the end steps is all about, is kind of okay, we did this and nobody seemed to like it or didn't want to adopt it, so.
Looks like Manjali
I was just kind of curious why states haven't, or
very
what the...
wisely left the room.
I can always ask her later,
Yeah, I think you should. So those were done, in sort of a reference-based approach. I don't think that they were embraced by all the states. I think one of the hard parts of nutrient criteria is a lot of time that the numbers that we need to protect resources are higher than people want to go. So, San Francisco Bay is an example. We have really, really high nitrogen and phosphorus numbers, higher than any other estuary in the United States. It's huge.
You're talking about what you sample from the water column, or are you talking about a criterion?
I'm talking about what's in the water column, yeah. But we don't see an impairment that causes people, we're doing all these studies to try to figure out what is the right number. And the reason that we're taking all this time and spending all this money, actually it's the discharge that are spending the money, is because at the end of the day, the cost of complying with these numbers is in the billions. And so we have to think in sort of a multi-dimension, right? So what are we trying to achieve? What's the cost of what we're trying to achieve? And what's the highest use, right? And so it's those are sort of the questions that we're trying to figure out, and they're very, very difficult. And that's why no one adopted the 304A criteria, because they were low. What a lot of states have done who have adopted criteria has embraced variances. And water quality variants are these tools where you basically say, I don't know if I can meet the water quality. We're going to write in a permit all the things I'm going to try to do to make, to address this, and review that over time. So it's kind of an incremental approach to trying to achieve compliance while we sort of figure out where we want to go. So I think I'm done. Anybody else? All right, I'm being saved.